In 10.3, we're continuing our discussion of hypothesis testing, but this time the parameter changes. This time the parameter is now the population mean, so mu. So notice similar setup as before. The only thing we're changing is the parameter, so the mean here, the value of the mean for the population goes here, mu naught. And notice that the null hypothesis still uses the equal sign, and we're still looking to identify the alternative symbol. So the setup will be mostly the same. It's changing the parameter that will be different. So let's look at example 1. The mean height of women in 1980 at the age of 20 was 63.7. Suppose that a random sample of 45 women who are 20 years of age is taken, with mean 64.8 and standard deviation 3.5. Determine if there is sufficient evidence to suggest that women are taller on average today at alpha equals 0.10 level of significance. Okay, so let me show you how we set up this hypothesis test, gather the evidence, and then we state our conclusion. So step 1, set up the null and the alternative. Okay, so for the null and the alternative, we're looking for the parameter of interest. Okay, keep in mind, parameter will either be p, mu, or sigma. Okay, it'll be one of those three that we need to try and identify. This can be the tricky thing though with 10.3, because I see mean. Okay, I see mean right here, so it's suggesting that we're going to use maybe this one. But then towards the middle, okay, here we see mean again, but then we see standard deviation. So maybe it's hinting that we're going to use sigma instead. So which is a true parameter that we're supposed to use if the problem is suggesting mean, mu, or perhaps standard deviation with the sigma? And this is the key right here. Suppose that a random sample, okay, so once you see the word sample, this mean is x bar, okay? Once you see the word sample, this standard deviation is s. That is not a part of this list, so we cannot use these, okay? So since standard deviation of 3.5 is sample, it cannot take the sigma. So in this problem, the mean height, this is assuming the population now that mean height in 1980 was 63.7. So the parameter of interest, we use mu, okay? In this class, the null hypothesis, again, will have the equal sign, and we need to identify the keyword for the alternative. Towards the end of the problem, here we get to see this word here. Does this suggest that women are taller on average today? Taller, right? And in the first video, we were able to see that taller suggests using a greater than symbol. And now we identify the population value. 1980, so this was a long time ago, old data. Here we had 63.7, so we're going to place 63.7 here and here. And once again, recall the purpose of the null hypothesis. The null hypothesis is the assumed true value of the population until it's proven otherwise, okay? So a researcher came in and is saying 1980 was a long time ago, okay? So maybe due to exercising, dieting, medical advancements, things like that, maybe today women are taller on average. So the researcher came in with the alternative claim that mu is greater than 63.7. This is how we set up step 1. For step 2, gather evidence. Okay. If we're making the claim that women are taller on average today, we need to gather evidence. And once again, p-value method is the one we'll use. It's a more practical use in this class. So we're going to compare p-value to the alpha level. Okay, we'll compare the p-value to alpha. So because we're using a different parameter, this time we're using population mean, the test will change a little bit in the calculator. Now to gather evidence, the setup in the calculator is to look for the command t-test. T-test is used whenever you're testing for population mean. Okay, in the previous video when we were testing for proportion, one prop z test, prop proportion, it was in the name of the function, that's using for population proportion. Here t-test is using for the mean. So let me show you where we find this t-test. So in the calculator, go to stat, tests, the TI-83 has it at number 2, t-test. The 83 and the 84 will both have this function right here. Now, the screen here looks different from the one prop z test. Let me show you what each one of these mean. The input, data, and stats, that'll depend on the problem that's given. Okay. If you were actually given a data table, kind of like example 2, I'm going to show you how we treat this whenever we were given data. Then we're going to have the input here at data, where you'll enter the population value. Recall that the population value mu naught is very similar to p naught. Think h naught. Go back to step 1. We would plug in 63.7 for mu naught. The list is where your data is actually plugged in. Okay, the list is where the data is plugged in. And then I'll show you how to treat the rest of it when we get to the example 2 video. But for our problem, okay, for example 1 doesn't have data. It's actually giving us the statistics already, the sample statistics. Okay, so we're going to go to input and change it to stats. And notice what it's asking for now. It's asking for the population value, sample mean, sample standard deviation. This is sample statistics right here, along with the sample size. So we have that information in the problem. Let's go ahead and enter. So mu naught, that's the value in step 1. Let's type in 63.7. Now for x bar, we're going into sample statistics. Suppose that a random sample of 45 women who are 20 years of age is taken with a mean. So now this is x bar 64.8. Standard deviation for that sample is given as 3.5. Once again, we took a sample of 45 individuals, so we'll change n equals to 45. And we'll approach this next step the same way. Going back to your hypothesis setup in step 1, we're looking to translate this symbol right here directly into the calculator. Okay, so we're just going to match the symbol here to here. So we're actually going to the third symbol in the calculator. That's going to match the alternative here. Now we calculate to determine whether we have enough evidence. Okay, and similar to the proportion test, there are 3 ways to gather evidence for t-test as well. The more practical way, once again, is p-value. We'll proceed with p-value, but MyMathLab does ask for another test. It only asks for the value, not to proceed with it. So it will ask for test statistic again. And in the calculator, this value, t, should actually say t naught. It should actually say t naught. This is going to be the value of the test statistic, and we will enter it as is. If it was positive, go ahead and enter it as a positive value. If it was negative, go ahead and enter it into MyMathLab as a negative value. So when MyMathLab asks, we'll enter the value, we'll give it the value 2.108. But once again, for us, p-value is the method of interest. We will compare it to alpha. Here the alpha level is 0.10. And again, think about that 0.10 as the room for error to make a mistake in our conclusion. We're given 10% room to make a mistake in our conclusion. Well, after conducting our test is saying hold on, you have about a 0.02 chance of making a mistake in your conclusion. So let's think about whether or not that's a good thing. If you're given 10% room to make a mistake, your test is saying you have about a 2% chance of making a mistake, you're under the threshold. And that's very good. When you're under the threshold, that's considered strong evidence. That's strong evidence against the null hypothesis, therefore we reject the null hypothesis. We can reject it. So again, 1980 was a long time ago. The researcher thought this was old data, okay, and we were able to gather strong evidence against that old claim. Therefore, we can reject it. Conclusion: reject the null hypothesis. At alpha equals to 0.10 level of significance, there is enough evidence to conclude that women are taller on average today.